In the last two videos, we discussed about what are the separable first order differential equation and then how do we solve them, okay? So the next thing we want to do is the first order linear ODE, linear ordinary differential equation. So what type of differential equation is called linear ordinary differential equation? So the definition is, let me give you a definition first and then we'll discuss some example, okay? So a differential equation of the form dy over dt plus p of t and then times y equals to, you say, q of t. This form of differential equation is called linear first order linear differential equation. So you should be careful about this. So look at this here, there is nothing in front of dy over dt. So the first term is the derivative term by itself. The second term is a function of t times just y, simply y. So the first term is the derivative of y, second term has just y, and times there may be some number or some function of t only, okay? And the right hand side has a function of t, another function of t, okay? There is no y on the right hand side, okay? Just a function of t. So you can say where p and q are functions of t is called first order linear ODE, ordinary differential equation, okay? So if the right hand side q of t is equals to 0, then we call homogeneous, okay? So it is homogeneous, all right? If the q of t is non-zero, if there is a term without any y, just t, that is the right hand side term, okay? You put that on the right hand side. If this term is 0, then we call this as a कान्छी के भयो
क्रेडिट कार्ड चेक गरिसो त
किन
मैले क्रेडिट कार्ड त स्क्यान गरेर त्यही छोडेर आइछु
ए हो र
छैन ब्यागमा हेर्छु छैन ज्याकेटमा नि छैन
ए कसरी याद भयो तिमीलाई
हैन अहिले मैले यो ब्यागमा मैले पर्सले हालिन कि जस्तो अहिले भर्खरै मलाई फिल भएर म छुटिसकेको पनि लिन लाएर छटपटी परे यस्तो हेर्छु त पर्समा देखिन बा
Sometimes you see a linear ODE as like this form, okay? For example, let's say AT dy over dt plus BT times y equals to CT, like this form, okay? This is also linear because you can convert this into that form. How? If you divide both sides by AT, right? So if you divide all of these terms by AT divided by AT and divide by AT, so you will get, that will cancel out, so you will get dy over dt plus bt over AT, right? bt over AT, right? That is like a PT, right? Y equals to CT over AT will be like a QT. So this is also the linear form. So the basic thing that is needed for the linear to be a linear equation is the first term must be the derivative terms plus, and then the second term must be a function of t times a y only, and then on the right hand side there should not be any y, just a function of t or constant, okay? That's what it is needed. So the next thing is, if there is a linear ODE, then how do we solve linear ODE? That is the next thing that we want to talk. So suppose you have a linear ODE given by let's say dy over dt plus pt times y equals to qt. Suppose this is given to you. Okay, so how do we solve this type of ODE? So what is the meaning of solution? Meaning that we need to get the expression for y. Okay, so here to solve a linear ODE, the very first thing is you need to write in the standard form, on this form. If this type of form is given, okay, if this type of form is given, then you need to divide by some function and get that dy over dt by itself for the first, and then in the middle term there should be pt times y. There's function of t times y, and then on the right side you need a function of t only. Okay, so after you write on this form, this is the first step. On the second step, you need to find integrating factor. That is, you need to find the value of e to the integral of p of t dt. Okay, find this. This is called integrating factor. Integrating factor. For any linear equation, linear first order linear ODE, first you need to write in the standard form, and whatever pt you get, you need to find e to the integral of pt dt. That's what you find out. Okay, so after you find out this one, in step number 3, what you do is you multiply all the both sides or all the terms by that. Okay, so multiply both sides by this integrating. So in the short, we denote the integrating factor by I dot f. Okay, integrating factor by I dot f. You multiply both sides by I dot f. Okay, so when you multiply both sides by I dot f, the left hand side, after you multiply, the whole left hand side will be changed into this form. The whole left hand side will be like e to the integral of p of t dt, whatever value you find out that, and you multiply dy over dt plus p of t times y equals to, what do you do? After you multiply, this is what you get, right? E to the integral of p of t dt times qt. That's what you get, right? If you integrate on both sides, or you can say, let's say this way, the left hand side of this will be changed into this format, d over dt. Okay, and then that will be changed into y times the integrating factor. That will be changed in that form. Okay, whatever integrating factor you get, the left hand side will be changed directly into this form, and then the right hand side will be just e to the integral of pt dt times qt. And then when you integrate both sides, number 5 is integrate both sides. If you integrate both sides, what do you get? On the left side you will get y times integrating factor, right? And on the right side you will integrate this thing. Okay, and then integrate this thing times qt dt, and then you may have to use integration by parts or integration by substitution method or any other method you learned in Calc 2. Okay, you integrate the right hand side, and at the end you need to divide by the integrating factor. Okay, to solve for y, you need to divide by the integrating factor, and then you will have just y by itself on the left hand side. So these are the steps. Okay, so next we will take several examples. Let us do question number 1 from the book. The question number 1 is y prime plus 4y equals to t plus e to the negative twice t. This is given to you. So the question is, you need to draw the direction field. Okay, so the question is draw direction field. You are asked to draw the direction field, and based on the direction field, describe how the solution behaves for large t. That means when t increases, for bigger t, see what happens to y. Okay, that's another question. And third question is find the solution. Find the solution. These are the questions, okay? So let us solve this question. The first thing you want to do is you want to draw the direction field for this, okay? So how do I draw the direction field using calculator? Is you write y prime equals to, you move that to the right side, and then you hit enter that, okay? And then you will see what happens to the, you will see it details what happens there, okay? So let me draw the direction field for that equation. So if you solve for y prime, you have dy over dx equals to negative 4y, okay? So you will get negative 4y, right? And then plus t plus exponential of negative twice t, right? That's what exponential of negative twice t, negative twice t. This is the given, right? Dy over dt equals to that, okay? So this is dy over dt equals to, maybe you need to write times and then times here. Okay, now it's good, okay? So negative 4y plus t plus e to the negative twice t, that's what we have, okay? So this is what the direction field look like, okay? For big T, it sounds like it is going to some linear equation, right? If you do, let's say, 10 to 10, negative 10 to positive 10, you see that? And also negative 10 to positive 10 for y, right? What do you get? This is what you get. All right, guys? So what can you say about this? So from here, you can say that all the solution, they converge to the solution, because if you draw a solution curve here, let's say, look at this. You see that? Here, you see that any solution, if you draw a solution line, it goes to some increasing line, right? That's what you get. Okay, so what can you say about this then? So if you draw the direction field, how does the direction field look like? So the direction field look like, you can say that the direction field is like this, right? And then from the left also, it is going like this, right? That's what the direction field look like, right? That's what we see from the direction field, right? Right? So what is the that's part A. That's part A. What is part B? It says when t increases, see what happens to y. Meaning that when t increases, meaning t goes to infinity, then y of t goes to an increasing function, right? Because it is increasing function. An increasing function. Increasing function. Okay. Now number C is you need to find the solution by using the steps that we discussed. Okay. Number C is we have dy over dt plus 4y equals to t plus e to the negative twice t, right? So what we need to do, we need to find out the integrating factor. So this is already in the standard form. The first term is the dy, the derivative term. Second term is a number or a function times y. And the right hand side, there is just function of time t. Okay. So what you do there is the integrating factor is equals to integral e to the integral of p dt, right? What is p? P is 4, because you can write this as so dy over dt and then p times y and then q on the right hand side, right? So that is the p. So that will be e to the integral of 4 dt. What is the integral of 4? That is e to the 4t, right? So what you need to do is you need to multiply all the terms. So you can write e to the 4t times dy over dt plus 4 times e to the 4t times y, right? I'm multiplying each term by e to the 4t. So e to the 4t times t plus e to the negative twice t, right? That's what you get. Okay, so on the left hand side you can write always the left hand side can be written as d over dt. So the product of y times the integrating factor e to the 4t. If you use the product rule on the left hand side, that's what you will get. Okay, because you can try getting that. So what do you get? So let me do that. So it is the product like f times g, right? So dy over dt times e to the 4t plus, because f prime times g plus f times g prime, right? So what did I do? I did f prime times g plus f times g prime. Y times the derivative of e to the 4t will be e to the 4t. It is e to the u, right? So what is the derivative of e to the u? E to the u times u prime, right? So u prime is 4. So 4 times e to the 4t. This is what you get. See, this is exactly the same thing there. Okay, guys. So left hand side is always y times the integrating factor. And in the right hand side, let me simplify the right hand side. You get t times e to the 4t, right? And then plus e to the 4t minus times e to the negative 2t will be just 2t. This is what you get. Okay, guys. So we need to integrate on both sides. So integrate. So what do you get? You need to integrate the left hand side. It is easy to integrate because you can just find out the just integration and the derivative will cancel out. So what you get is y times e to the 4t. This is what you get. On the right hand side though, you will have to do integration by parts. E to the 4t times e to the 4t dt plus integral of that will be e to the twice t over 2, right? And then plus c. You see that? That's what you get. Plus c. Now you need to use integration by parts here. Okay, guys. So there are several ways to find out to use the integration by parts. Okay. So one way is just use the formula. Okay. What is the integration by parts formula? There are several forms of the formula. Okay. For the integration by parts, there are several forms. You can do this like this is u function. This is v function. Okay. So you can do the derivative of u and you do integral of v. Let me show you how to do that. So for this integration by parts, I write u and then dv. Okay. So find the derivative of u. What do you get? Find the derivative of u. So u is t and then this is v is dv is e to the 4t. And find the derivative of u. 1. Find the entire derivative of this. You will get e to the 4t divided by 4. And find the derivative of this is 0. Find the entire derivative of this is e to the 4t over 16. After you get 0 in one of the column, you always stop. And what you do is you first do the positive multiplication t times that and then alternate with the negative one. Okay. First product should be go diagonally positive and second is negative and then positive and negative like that. This is one of the way. So you can use the other formula that you know, the integral of u times v. Okay, so you can use that too. So you get the same thing. Okay, so what you get is on the left side you got y times e to the 4t. On the right side, so you get t times that. What you get is t times e to the 4t over 4 minus, because that is minus. Okay, 1 times that is e to the 4t over 16. That's what you get, e to the 4t over 16, and this one is plus e to the twice t over 2 plus c. This is what you get. Now you need to solve for y, meaning you need to write y by itself, right? So this means that you need to divide all sides by e to the 4t, divided 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 by e to the 4t. What do you get? You get that will cancel out. So your final answer will look like y of t is equals that and that will cancel out, right? E to the 40 divided by e to the 40. So what do you get? T over 4. And this cancel out, negative 1 over 16. So this move to the top or you can move this to the bottom. You can write plus 1 over 2 e to the twice t. Did you understand this? Because if you move this e to the positive twice t to the bottom, you will get e to the negative twice t, and you write the same just common base, and then write negative twice t plus 4t will be positive twice t 2t, and then plus this one can be written as c over e to the 4t. If you want to write this like a nice format, what you do is move everything, all these the t function to the top, so you will get like this: c times e to the negative 4t, right, plus 1/2 times e to the negative twice t, and then plus t over 4 minus 1 over 16. That's what you get. Okay, guys. Now you can see that what happens when t tends to infinity. When t tends to infinity, this goes to 0, right? This guy goes to 0. This guy goes to 0. This guy goes to 0. So when t tends to infinity, the function is similar to t over 4 minus 1 over 16. So you see that, okay? That line was like t over 4 minus 1 over 16 kind of thing. That line, okay? So when t tends to infinity, this goes to 0, this goes to 0, because e to the negative infinity will be 0, e to the negative infinity. So the function or the solution is similar or asymptotic, you can say. The asymptotic to t over 4 minus 1 over 16. So this is how this is the very nice example on all, with all the steps on how to solve the first order linear differential equation by the direction field and by using the steps. Okay, guys? Thank you.